Morning, and this is Bill Foote. This is MBA 611, Advanced Data Analysis. And what we're going to do in this course is splice together both the so-called science, the mindset, the system model that we're going to be thinking about with its calibration and inference. The first part is system dynamics. The second part is Bayesian data analytics. And what we're going to do is pull these together using three platforms. The first one is going to be Vensim, and we'll show that in a second. R Studio, which will provide us with lots of good processing, sensitivity analysis, simulation, a lot of what ifs that kind of parallels some of what Vensim as a system dynamics generator will do. But we'll be able to read a model in that we create, and we're going to be able to create it visually, much like the reversed images back here. The third platform is Stan, a probabilistic programming language. Without much further ado, let me pull up this. Hopefully you can see this clearly. By now, you should have gotten an email for the course from Manhattan College. SystemDynamics101.com is the domain I have for carrying this course. It has two major components. One is the basics, a 7-week course that we have just concluded. Concluded it yesterday. We're still working on it together. And in these basics, we build a simulation of a B Corp, a benefits corporation, using a business canvas. And we go through 5 weeks of work to get to the point where we can do that. And then the 6th and 7th week, and I'm telling you all of this because it's going to be the same kind of approach. 6th and 7th week is a project, something that we can actually sink our teeth into, get our hands around, arms around, and actually work. The System Dynamics Inference course, which is what this course is, and during spring of 2024, we go, I think I got these dates right, from March 4th through April 21st, 7 weeks. Yeah, it's kind of daunting in one way, but it's going to be very revealing in another. We're going to use VensimPLE. Okay, we're going to use our programming language with RStudio, now called Posit, the tidyverse, and Stan. That's Stanislaus Ulam, who basically created the notion of Monte Carlo. That's probabilistic programming, otherwise known, aka Bayesian data analytics. So we're going to put all of these things together because it's not enough to make up a model out of a mindset. It's better to simulate it. And so, yes, you simulate it and do tabletop exercises in a group, and people feed pros and cons, and finally the group and the leader of the group perhaps affirms the response that the group comes to, feeds it back to whatever it is. It might be a decision, it might be to further work. But that's one step. But when we want to do advanced sensitivity analysis, advanced scenario analysis, take different cases, for example, we want to use something like our programming language. And so that's what we will use. You can use Python, you can use Julia, you can use Fortran for crying out loud. But this is what we get. It's very difficult to do this in Excel. Okay, that's the other piece of this. And if we attempt to go down here, You see, they'll always have news and updates for you. There's at the end there's a project, and this is not the project workbook. This is for the 645 folks who are finishing up. But it should give you an idea of when you click on this what that is. My contacts are here. I think we got everything. We're going to use this Zoom for now. Might be able to change it to my standard Zoom ID number. I'm on GitHub. You should be on GitHub. We all should be on GitHub. It's a standard repository. Pretty sure Microsoft now owns it. Use GitHub. It's the standard professionally in data analytics, and we're going to consider ourselves those professionals. Here's my Manhattan address. Don't worry about that fax number. I don't think anybody knows where that fax machine is. Maybe some folks in the office do. We're going to have office hours online on Zoom, Saturdays 10 a.m. to noon. People have not cottoned to this, we would say. So let me know when you can meet. Text me, all right? Let me know who you are and where you are, what course. And that's my text. That's my mobile number. Several learning goals you should look over. The origins of the course have lots of interesting detail. A lot of Ventana system dynamics stuff here. I'm going to be adding to this a little bit, but yeah, it's math. But you're not gonna do math, okay? But the math is in this first 84 pages. I wanted you to know that there's a very solid logical foundation for what we're doing. Numerics, yes, Fortran, but we're not going to be doing Fortran. All of this stuff is going to be under the hood, but we do need to understand how and why it works. Numerics meaning if you have had any excuse to have taken calculus whatsoever, who needs an excuse for that? Probably one of the greatest ideas in science and technology ever, invented by two people who wanted to express the glory of God in this incredible idea. Because they saw it in all of God's creation everywhere. That's Leibniz and Newton, and I'm using their language. Reverend Bayes, you know, a lot of this stuff was invented to express all faith-based. All of the Arab and Vedic scholars, all of the Chinese scholars who invented all of the algebra that we will be using did this for this purpose. So it might behoove us to think about that for ourselves. Leaving that aside, Jay Forrester, this self-study course is probably the best. It's like 45 modules. And if you do go through this, you will be very close to being at least journeyman, close to master expert in all of this. George Richardson, John Sturman, Craig Kirkwood, Tom Fiddeman, I mean, these people, Eric Prout in the Netherlands. There's all sorts of resources that we can and will look at. Please read the premise and manifesto. This is how I think through this. This is how many of my clients over the years and colleagues think about this. But the ultimate thing we're getting at here is surprise, informativeness. And we're going to compare scenarios, two different models, coming from two different scenarios. We're going to compare and contrast them using an information criteria in this course. And that's going to be where we're going to go with that. And that's going to bring us even closer to what is inside of our mindsets, because these scenarios express our mindsets. Okay, we go up to the top. And the basics course, which has already run, you might walk your way through it. Very interesting stuff. We use a couple of books. This is on Kindle, I believe. and I say Kindle because it's an EPUB format that I can actually get to and pay for. We can download Vensim, and that's what you should do. Absolutely. Just download it. Here it is. It's free. Get it. Say you're a academic person, right? Which you are. You're enrolled in a course. So the E stands either for evaluation or education. I have an enhanced version of this, and you'll see what that is. That I think it's now priced at $89 a year. But I'm willing to do that because I want some of the pieces of that that are very, very useful. Very useful. It doesn't have one piece I really need, unfortunately, which is array-driven anything. So I think in arrays. So you have that, and let's see if I can do this. Yes, it does bring me back there. That was the course that we already have, and you have it as a resource. Add inference. So, stir, add a little salt and pepper, and it tastes good. Add inference. And this is another 7-week stretch. The 7 weeks are a compressed version of a 14, 15-week standard semester course in this term. Now, all of these are under construction. I got a little bit going on here, but okay. We are in week 1, and we're getting started. Okay, I'm gonna be about every day. I'm going to be refreshing this, so refresh it every day for yourself. And here's a little refresh button up here. Okay, form teams. Okay, get in touch with each other. And how are you going to get in touch with each other? There's 2 ways you can do that. You can reply to the announcement email. There's a forum on Moodle. I do it that way. I will have something called the wall set up for you. Okay. Right now it's set up for the basic course, System Dynamics 101, the basic course. I'm going to set this up for you because I want you to share thoughts on your modeling experience, something about the ethics of our modeling experience and our relationship as analysts to decision makers. We're making decisions too, but we're not just pure automatons. All right, so and we're not cogs in a mechanical universe. Okay, although we often feel like that, and that's because there are people who set it up that way, and becomes a little bit difficult to manage. Okay, so you can see I lost my. There we go. The wall is not set up for that yet, as you can see, nor are projects. By the way, this website is written in R, 100% R, something called R Markdown that we're going to play with. Lots of stuff. This is the book that will get us where we need to be in this course, about 3/4 of the way there. The other quarter of the way is going to be a couple of articles and a tutorial using materials that I introduce here based upon a book that I have used in this course for quite a while. And the switching of gears is due to a need to focus on how do we build the model for these things. Statistical models are just not linear regressions, huh? It's quite a bit more interesting and more complicated at the same time. The System Dynamics Review article by Jer Andrade and Jim Duggan. Jim Duggan's been doing this for a little while. And the calibration tutorial he has is going to be where we're going. Vensim itself, Tom Fitterman there has some very interesting notes on calibration as well. How do we take a model and calibrate it? Okay, that's it. Simulate it with stylized data. Calibrate that. Okay, so part of this is generative, yes, generative AI, generative approach. And the modeling that we're going to do is actually being used by a number of folks who are doing generative AI with these models in very specific areas, such as you can check out body logical, for example, machine learning and system dynamics models. Machine learning meaning Bayesian-based information, entropy-based inference alongside of a mindset model generated in system dynamics will yield very interesting things about cancer, wellness, managing an epidemic, managing human intervention in physical process. So that abstraction. This calibration tutorial is where we're going to be going after next week. This week we're going to just download everything, play with a model, a simple model. And next week, we're going to step that up a tad and apply some Bayesian inference to that model, very simple Bayesian inference, and you're going to see what that is, and I'm going to show you a couple of things in a minute here. The week after that, though, week 3, it gets serious. This is where we're going to have to use a probabilistic system to solve ordinary differential equations. All of that is under the hood. Okay, we're actually skipping over 3 or 4 courses that you would take as an engineer or a scientist or a mathematician: differential equations, numerical analysis, and so on. We'll know enough about those things to be dangerous. And that's why I put Harry Hochstadt and Joel Verziger there, just to give you an impression of how dangerous we can be. But that's not our aim here. Our aim is to take a mindset, be able to represent it, be able to simulate it, be able to play with synthetic data, and then having assured ourselves we got the right model statistically, high density probability interval wise. We don't use confidence intervals in this space at all. We use credibility intervals or high density probability intervals. We don't use standard hypothesis testing either. What we do use is compare how much information is leaked from a model. If more information is leaked from model A than model B, then we choose model B. Okay? The greater good issue is involved in that. So here's this is what it looks like. Okay? Is the way he uses a different thing than Vensim called I think. And we don't use it because it's expensive, but it's basically the number of susceptible individuals, and then there's a flow to the number of exposed individuals, another flow to those who get infected, and another flow to those who recover. It doesn't tell us what C is. If you're infected, what happens then? Okay, so this is a collection for what happens going from E to I. Okay, that's what it's doing. That's what this notion is. This is a derivative. This is an integral. The idea is still there. And what we're going to do is learn how to read this in. And we're actually going to have to use some what are called packages to do that, read SDR. And these packages have this is a vignette from it, actually. Show us how to use it so we don't have to invent the wheel. Yeah, you need to know very little about differential equations here, Jair. Yes. And then how to access information that you've just collected from a model you've read in and transformed into R. See, you have different parameters here coming in with different values. We build a synthetic data model of this and run it. And that's what it looks like. Sound familiar? Look familiar? It also looks like the Bass diffusion model, which we use in marketing. Oh, it also looks like the innovation model inside of a project. It also looks like the advance and decay model of populations in general that we might serve, or obsolescence of machinery that we might use. Again, the names matter. But I mean, they're not names anymore. They represent, they stand in symbolically, joined with symbole, with a whole universe outside of our minds that we're building and part of. Okay, and here's more. This is where it really gets interesting, because it builds a model, and we're gonna learn how to build this model. It is straightforward in the sense I can explain every single line, and so can you. You see S to E, you see dy dt, that's the flow, okay, and so on and so forth as it goes through. Okay, and it's solving for it. It's transforming variables. We're going to do all the same things. And here's the thing. Here's the thing that it does under the hood. This is the integration. Okay. And then we get a simulation. We're not going to play too much with this. Jair already knows that we just want to get to the bottom line. And this is the rest of the code. Yeah, it took 20 seconds to do that job. Not an easy thing. And then some diagnostics. And we're going to learn how to do this. We're going to spend some time with this part, the diagnostics part, and we're going to plot it. So remember the original scatter of incidents, the number of, and days. So how many people visit your various car dealerships? And we would have different regions. And that would be a hierarchical model of some sort. Look up hierarchical models, and that'll be interesting in and of itself. And this is not meant to scare you away. It's meant to encourage you how to do this. We're actually going to look at this thing called a negative binomial model. It's a little better than the Poisson model that we may have learned. There's one more parameter that we could tweak to play with the a major problem with the Poisson happens to be that variance is just completely related to the very parameter that we're estimating, which is the lambda, how often something happens, the intensity. And then ggplot. So we're not going to have to invent all of these wheels. They've been invented for us. And then here's Cumberland, the 1918 influenza pandemic in Maryland, the number of cases per day. Okay, U.S. Public Health Service in that, and that's very interesting data. We have other flu data. Flu is an interesting problem from a business point of view, other than the fact that it hurts a lot, and a lot of money is spent in curing it individually, but it's a major supply chain disruption. If all of the credentialed and licensed operators of machinery at your plant all of a sudden come down with it, you got a problem. You have an outage to manage. And models like this help us understand when things happen. When we have the Poisson model, we can pull out of that the time to the next big event. Okay, that's one of the important things. Now, inference all the way down through here. I'm doing this to show you that, one, it's all doable. We can just dump our model into this and pop it out, and good. Okay, that's the minimum that we should be able to do. It'll just pop out. But when we get to diagnostics, when we get the posterior predictive checks, we want to know what this means. See, it's slightly shaded there. How did we capture that extra bit, and that extra bit is coming in from this minimum to maximum, the 75th percentile, the 97.5 quantile. That's where that's coming from. Now, there's one on the bottom too. So we can expect events to happen in this time. Basic reproduction number is a famous number. Mean generation times, how yeah, there's all sorts of other things we can do which we may or may not need to get into. I'm going to want to get into it because it's interesting, and I want to apply it to I've been through several pandemics, 1957, 1959, and several recently, of course. And it's one of the reasons why I still can't do the 12 times table. Talk about a mathematical supply chain interruption. I still have to think about it. I was in school. So I just wanted to show you this to show you where we're going to end up at the end of the course. You're going to be learning how to get there. Okay, that's the idea. Access. Yes, VensimPLE is thanks to our ITC and Wyatt especially getting this and people agreeing to a license. You can download it for free. Okay, it's not hard to do. Some people have had problems with the Mac. I don't know why. It's probably the running system. This will not run on a Chromebook, which is why we need this up here. Absolutely not. None of this will run on a Chromebook unless you buy an emulator. R and Stan, again, remote. You can go here as well with the cloud, and you can otherwise put it on your machine. Long and Teeter, which is a book I recommended, okay, this is all online. How to download and install, follow it, it's still the same thing. Install RStudio, follow it, it's the same. Starting it, playing with it, gee whiz. Let me see what comes up when I start it. I put my tray down below it. Probably can't see. R, okay, the lovely R comes up. More lovely R. It's looking for an image. I think one of the last images I had, I have no idea what's going to come up. It's going to be interesting. Almost there. Almost there time-wise too, I think. How come this is taking a while? It does sometimes. And patience. Bear all wrongs patiently as a gift. Well, especially from, oh, look at these. What the heck is this stuff? I don't know what's going on here. I got all sorts of things here. Oh my gosh, look at this one. I actually want to show you this because, no, I don't want to do that. Okay, so this is our markdown. Okay, and I'm working a model here. I'm doing more than that. Oh, here's the stand model. Okay, and the reason why I'm working this model is it's got another approach reaches this, yeah, Bayes QR, right? Quadratic programming, port results. I actually build a simple parser based upon the Richard McElreath parser. In rethinking that, I cite his book, and it's a good lesson in parsing, which I have to tell myself every now and then. How do you take a model that you built and translate it, much like a musician would rearrange it for the orchestra, shall we say. And there's some stops there and so on. If, then, else. I'm doing the asymmetric Laplace distribution. That is a really important distribution for quantiles. It's the distribution of observations around a quantile. Okay, that's pretty important. It's asymmetric because quantiles have a lot of asymmetry, and it peaks right at the quantile. And so that's an important thing that we're going to start talking about. Odo, yeah, price and odometer. Yeah. This is actually from a project I did many years ago for an investment bank that had a book of least planes. Yes, odometer. Yes, number of hours of operation for the Rolls-Royce and GE engines. Okay. Then there's a price associated with it. So just translated that into cars. That's the same project, almost the same data. The spirit of, yes, lots of spirit. And I go through how you do this. This is a good exercise in something called the quadratic approximation to a Bayesian model. And that was known by Marquis de Laplace in 1830s and 40s. He figured that out. Okay, everything looks like the bell curve. So just wanted to show you all the cool things you could do with our markdown. And as you can see, it runs away with me. And I have it. I don't even know if this is going to save. You can save this. I don't even know if that's going to work. No, I can't do it. Okay, I can get it though. No, it won't do it. It's in another directory. Anyways, I'm not going to play with that any further. But what I will do is go back to this. This is our studio. Exiting, interrupting. I guess you can interrupt it. Don't interrupt me. Mailing lists, getting help, all sorts of cool things. And then Long and Teeter run you through some basics. And you should just go through these basics. They're not hard to do. How do you print? How do you say hello world? How do you set variables? How do you delete variables? They have a problem, they have a solution. Oh, that's just that easy. We're setting variables. Now we do the square root if it exists. I don't like square roots because they often don't. And the square root of 2 doesn't even exist. We don't know what it is. We think we know what it is according to an algorithm to a select number of digits. And you're going to hear me talk like this a lot. Right? We are within the computational bounds of our minds and our mind's machine called a computer. We don't know what it is. Same with pi. But, we just say wave it and say willingly suspending disbelief in the ongoing series, which keeps adding another digit to the number. We play with that. Okay, so there are several recipes in here. How to navigate, input and output. Do you have to read the whole thing? No. Can you read data from Excel or CSV, separated variables? Yes. Yes, you can. I mean, this is the workhorse. Okay. You access a database. You can get into MySQL. Yeah, you can do all those things. And then there's data structures. We're going to be using the tidyverse mainly, which is a subset of a data structure. There's strings and dates. We're not going to do hardly anything with that. Probability, very interesting. Generating random variables, generating combinations. Not hard to do. Run if. No, it's R uniform. Okay, I always say run if. Run if one sample, 0.9. This is a number between 0 and 1 with equal probability, right? There's another one called the beta function, does the same thing. The beta 1, 1 function, roughly the same thing. And we go through all sorts of things that you can do with these. Okay. I come back to this when I can't remember how to do something, which is most of the time. And here's the other thing. Always use set seed. This gives you the ability to reproduce anything in the future. So that's R. Okay. What does system dynamics look like? Let's look at system dynamic models. Oh boy, no, you don't want to look at the beer capacity model. So John Sturman runs. So if you go to Sloan School, you're a freshman, just joining or transfer in, and certainly graduate students do this as well. First thing you do before you walk into a classroom is you do what is called the beer distribution problem. System dynamics. MIT Sloan School believes in this tremendously. Here is a joint venture demo model I put together. Hopefully I didn't destroy too much. I don't know why it couldn't come back. Come on. All right. Here's a joint venture between A and B. And this is how we would model their joint venture. And look at how capital moves. So we can make little graphs and so on. This is very useful. And those of you who've already taken this course will know how useful it is. And I can even change this. And if I run this, there we go. You can see the move. Here's a step down. Capital A is not giving so much capital anymore. And B, A to B is the contribution. B to A is the other contribution. ROA is the return on this number, not capital. ROIB is the return on this number, the investment. Okay. There's an initial amount for each. And you can see what happens. You can now play with it. What does the contribution do? What if it's a negative contribution? What does a negative contribution mean? Negative contribution is like loans and deposits, assets under management and redemptions. Okay, interesting. You can see it produces what are called oscillations in this situation. I just modeled the hedge fund, basically. And that's interesting. This is a stock. This is another stock. This is an integral, another integral, and this is a derivative of flow. Okay. So this gives us an immediate calculus course right here. Yeah. But useful to us. Okay, this is where I want to go with this. This has already been a little bit too long, but I want to get into one more thing with you. And to make sure that you see it. Get back to there we go, the cookbook, and back to this requirements. Okay. Yes, there will be 5 assignments, 13% each. That's a lovely prime number and a very lucky number in, well, Scandinavia generally. Well, I think that's changing. That's 65% of your grade. I am in the habit of simply giving you the credit with comments for you to fix it, to get it right. It's on you to do that. Get it done mainly, or you don't get the credit, of course. This will typically include an upload of a model. Okay. Yes, so you just have to follow the directions. 25% of your final grade is a project that we will do during week 6 and 7. You will come up with your own ideas on that. If you don't have ideas, I got so much data, I don't know what to do with it, to feed some ideas. Participation is worth 10%. We typically do this in online asynchronous courses like this with a sharing platform like Blogspot or something like that. That's what we'll do. We'll have a share. Other matters at Manhattan College about academic integrity and anybody with disabilities who needs any kind of accommodation, just let me know, let them know, and we will work it out for you. We mold the course to you, not the other way around. I mold jobs around people, not people around jobs. I was always known for that, and as a manager, and taking the task for it at the same time. Yeah, interesting. As we go down through here, these are all going to be, this is under construction. It worked good. Okay, and this basic model is also under construction. Good. Okay, we'll be popping those in tomorrow. Get and read Duggan 1 and 2. Get, this is for free. Chapter 1. If it isn't free, I'll send it to you. You know, when you get Duggan, this is kind of where we want to go by next week. Let this scare you. This is in Duggan, okay, directly in Duggan, chapters 1 and 2. Okay, so it's all right here, all in one thing, and it works. If you see it here, it worked. All right, very important, and we're going to walk through that together. This is going to be set up a little bit differently. It will be this block spot. It looks like this. Yeah. Week 7, 10 comments. Lots of great reading here. There we go. Here's my thing. Sorry, Ariana. All students, all of you, and some very, very good commentary about this. I'll be asking similar questions so that you know what that looks like. And finally, over here, okay, there is a workbook. Now the workbooks here, for those of you who are in the other course, are going to be week by week. So you're going to get a different workbook. It is basically a Google form. Okay, and this way I get a record of it, and you will have your own record, but I can reflect to you what you submitted directly. A little bit easier than other learning management systems. I decided to do this a long time ago, and it seems to work well. Okay, so that's where we're going this week, and with the syllabus. And welcome again. The overview video is always this long, and sometimes longer, because we have a lot to cover. The next one, we're going to build a simple system dynamics model together. This very model right here is going to be read in. Customers, recruits, losses, I'm going to give these different names. I'm also going to add switching. I want to know how many people switch out and what's the accumulation of that. Accumulation is an integral again, a cumulative sum. And I want, let's get over the math phobia thing and get into how can we represent these things logically, and then pose all of the interpretive meaning and apply our wisdom and experience and use this to help us make decisions. With that, I want to thank you for your very kind attention. And again, welcome to the course. And as you begin to form teams, always remember that daily, please encourage each other and do it while it's still today. It might be a simple phone call saying, was thinking of you. How's the project going along, or how's that thing we talked about going along? And make yourself available. It's a very hard thing to do in our environment, but something very good for us to do. Okay, I will leave you at that. And again. Thanks. So much to learn, huh? Yeah, got that right. Take care.